So one of the NAV bottleneck today that you can see on PerfTop when you get packet in and out VMs is the vHost-User Enqueue DQ. So that's pretty visible, and that's basically a mem copy under the hood. So Zhihong Wang from Intel is going to present today how to accelerate and remove that bottleneck for NFV.
Hello, can you? Okay, great. It's really great view down here. So just one talk away from lunch, I was instructed by Thomas to speed this up. So unfortunately, Jerry cannot be here today with us due to some conflict. So I'm Zhihong from Intel. I'll present this simple idea during the next few minutes. So the first, I'll go through some introductions, and we'll see the problem statement and the challenges, and finally we'll go to the solutions. Okay, first some background introduction. Virtual is a widely used virtualization interface and widely deployed in a lot of use cases. And you know, Virtual got a backend device, virtual device, which is called vHost-User in DPDK. And by design, vHost-User will be responsible to do all the copies inside and out of the virtual machine. And by the way, now Virtual also supports the container use case, but the methodology is all the same. And DPDK got a vHost-User implementation, which is one of the fastest implementation, and also it always keep up with the latest spec, the latest features very fast. And so vHost-User, DPDK's vHost-User is really deployed in a lot of virtual switches. So you know, in virtual switching use cases, we got limited core resources for the virtual switch, so where the vHost-User will be running. And that's naturally leads to the question. The problem is that because the limited core resources of virtual switch will be responsible for all the copies into the VM and out of the VM. So that's that's just but that's the way it is. So the problem we need to solve is how can we accelerate the memory copy of the vHost-User. Okay, so I'm going to talk a little bit about the CBDMA, and we can go look this up if you don't know it already. CBDMA is a DMA engine in the processors, in Intel's processors, and it's very efficient to perform the memory copy operations. And the best part is you don't need any CPU cycles to actually help the memory copy. So the idea is really very straightforward. We have a vHost-User implementation, right? And the Enqueue, DQ. Yeah, we're talking about the Enqueue operations first today. And in the Enqueue operations, we have several like ring operations and memory copy, and then some update of the indexes, those kind of stuff. The idea is very simple. If we want to accelerate this memory copy part using CBDMA, there's two ways to do that. One way is just using the synchronous mode, which means we let the CBDMA to do the memory copy, and the CPU wait until it's complete. Then we update the index, and then just return, the function just returns. And another way is to do it asynchronously. So the CPU will return as soon as possible, and just leave it to the CBDMA to take care of that. That's a asynchronous mode. And here is a demonstration. Yeah, it's pretty straightforward, right? And by the way, the CPU here on the top, we can see here is what we mean by the synchronous mode, and the latency will be, I mean the efficiency of the pipeline will be it should be low. And by the way, the CPU here does not necessarily only means the vHost-User CPU cycles, but it means the whole application CPU cycles. Say, like in virtual OVS, there will be vHost-User memory cycles, and you will have a whole bunch of pipelines waiting to be executed, right? So there's a almost we can be certain that the CPU cycles will be longer than the CBDMA cycles in most cases. So that means the CBDMA memory copy, let's say the overhead can be hidden. Okay, just a few challenges. The idea sounds very simple and it sounds great, but still we got a few things to be solved. The first thing is, how can we leverage CBDMA very efficiently? Because it's a device, every kind of device have their own characteristics. So that's one challenge. And the next one is, how can we just let the CPU and the CBDMA do things really, can they work together very efficiently? Can they get along with each other? So because the current vHost-User is designed for CPU, right? Okay, so this is the second one. And the third one is, there's a slight change of the semantics. Like the enqueue operation, if we, in current semantics, if the enqueue is done, I'll return how many packets have been enqueued into the ring. And so, now we're using asynchronous mode, which means when I return, the memory copy might not be completed. So how can we deal with that? Right. So this page gives the solution to each of the challenges. The first one, we can refer to Jiayu's talk last year in US Summit. It's very comprehensive and got a lot of data there. And the second one, so basically we just need to look into the pipelines, the details, to decide how can we do this, mix them together. And we'll have some details later on. And the third one, how can we solve the semantic change, the semantic difference? So we're thinking about provide a new PMD, because the enqueue operation got its own semantic, but if we just provide a PMD, the args, the TX function, then the buffers will be managed inside of the PMD. So there should be no problem to the applications. And let's take a look at the pipeline. So this is very abstract level of the pipeline. Basically, just reading descriptors to know what kind of information I want to send, right? The packet information, and I just do the copy, and then I just tell the driver to, okay, I'm done of the whole stuff. So it's very high level, but it's good. It's detailed enough, and so if we take a look at the presentation Jiayu did last year, the CBDMA is very efficient and doing large copies. So obviously, the second step here, which is to copy all the buffers, it naturally will be we want to give CBDMA to do that, and So is it enough? There's one little problem is that we need to update the use ring index in the so just to tell the driver that you have packets coming in, and if we want to do this asynchronously, we also need to let CBDMA to handle that part. Even though it's very small copies, it's not that efficient, but it's good enough, because otherwise CPU will need to wait until it's complete and to update that. So there will be no okay, just to make it very complicated. So it will look like this after we integrate the CBDMA into just mix them together. Sure. Right. Yeah. The order is it will be completed in order. Oh, you mean the copy operations in CBDMA, right? Oh yeah. Okay, let me explain a little bit. That when the CPU done the first operation, it will enqueue some requests into the CBDMA, right? And it will go to do the third step, which is to store all the descriptor address to the user string, and then it will also until then, but at this point it's not done because CPU do it in the batch mode, right? Burst, and after it's done all the 32 packets, hopefully, then it will update the used index and let the driver know that the packet's coming in. So at this point, you will, because all the other memory copy operations are already enqueued, and then finally I will enqueue one final one, the last one to update the index there. So after all the memory copies done, and if you don't need to worry about that at all, the ordering stuff. Yeah. Okay, and let's back to the final challenges, which is how can we solve the semantic issue? If we just provide another enqueue operation, it's a little bit difficult because like in your DPDK, well, I read the code that the OBS will call the enqueue operation and then will free the buffers, right? That's where the problem comes. So the way we're taking right now is to provide a vHost IOAT PMD because CBDMA is a device. So we and there's another point of in this is that I know there's a few other options, design options we can take. For instance, we can do some abstraction in the library, but that part will also take that into consideration. And finally, we think this is the best way to do that. The thing is, each device will got its own characteristics, and it's very hard for us to actually do the abstraction and provide a single library and some operations in the library, and then or ramp up the single PMD. That doesn't make that much of sense. So okay. And here is an example, the how to create this, the command line. We can take a look at this, and we can have some basic understanding on what the design looks like. So, but right now we're only working on the enqueue, but the dequeue is there. There's no it's on our to-do list. It's just we do this step by steps. Okay. And some takeaways. It's very simple, right? We just want to accelerate the memory copy. We just want to let the CPU to do more like the precious workload. So CBDMA is a good way to help. And I could do it in asynchronous mode, can bring most of the better benefits here. And vHost PMB, we're introducing new vHost PMB to do that. And by the way, we'll send out the RFC patch pretty soon, I guess. So if you have any questions or if you have better suggestions on the design and anything, just we can discuss on the mainnet. We can discuss here today, now or offline. And the future work, we will work on the dequeue operation, and also we want to make the queue and port shareable. Right now, it's only one queue for one for one queue in the vHost. Yeah. Questions?
Thanks, Zhihong.
Okay.
So, okay, I got a mic, so I got a so basically, you have asynchronized the CBDMA and you offload to memory copy to improve the performance, stop the CPU clock. I just wondering, do you have any measure, like how much percentage the performance is improved?
Yeah, yeah. I know this here is a Userspace, right? We thought first just want to take a look at the design and the performance numbers. We're working on that, and we definitely will be ready when we send out after the patch.
One question about vectoring. Do you plan to implement it for vectoring as well?
Oh, vector?
Vectoring, the Virta 1.1 ring.
Oh, vectoring, definitely, yeah. Yes.
So it's in the plan as well?
Yeah. It's also in the to-do list.
And a second question about bigger packets and smaller packets. Do you plan to select it based on the packet size itself? Like?
Yes, I think so.
Okay.
Are you planning to add any generic memcopy offload API to DPDK?
Yeah, that was the original thought, but it turned out it's very complicated, and we can discuss this offline. I'm sure, but I want to go to lunch, but so I won't take too much time because it's going to be a long discussion, I think.
Okay.
So you don't intend to add this to the vHost library? You just wanted to make a new PMD?
Yes.
Okay.
About the CBDMA engine, for example, in the case of the DQ operation, when it will copy from the descriptor buffer to the mbuf buffer, will it does the data go through the L1 cache or?
Sorry, I didn't.
When there is a copy done by CBDMA, so I understand that it is in the CPU, but does the data go through the L1 data cache of the CPU, or it can skip it if it's in L2, for example?
I think no, I think it won't go to the L1 at this. Yeah, it should be go to the L3. Yeah.
Depends where the line is located. Right? If you produced and it's in an L1, you'll suck it out. So. Oops. So the question was about. So let me try and answer. So it depends where your data is located, right? If you're produced, you'll end up and it sits in L1. Ultimately, the read request makes it up and sucks the data out to the LLC, and from there it goes out. Yeah. So, and just a generic comment on maybe CBDMA, because there's a lot of folks probably interested in performance. As soon as your data set size is usually about 128 bytes to 256 bytes, then it makes sense to start using the DMA engine. So the scripter writes in order to set up the DMA engine are typically quite expensive, right? So for 64-byte frames, it's usually not very conducive to use the DMA engine, but as soon as the data set sizes are bigger, 256 bytes or so, it starts making sense. So and that's sort of a generic guideline, but we're working on performance data.
Thank you.
Okay. Thank you. It works? Yeah. So this is the end for this morning.